All right, so this is for question number 2. Let me see whether this is the slightly more involved one. Yep, this is the more involved one. Okay, so the first part, with x and y, it's really kind of the same thing. We are really just collecting the first item of every two tuple of f. So there we go. 2, 3, 6. 6 here, 3 here, 1, 4. 1, 4, 5, and that's it for x. And then for y, we are collecting the second item of every two tuple of f. So that would be 11, 6, 3, 5, and 10. There we go. And just by the way we construct x and y, they are basically the domain and the codomain of the function f. So it is going to be true. Okay, it is f is a function when we consider x as a domain and y as a codomain. All right. So now we have this one is harder. Okay, this one is harder because C, D, and E are supposed to be in F, but the constraints involve A and B, which are not in F. Okay, so we kind of have to read this one carefully. All right, so the first part here, basically says, okay, these are just placeholders. C, D, and E are basically placeholders. They are basically, elements from the domain of f. And obviously, since we already know f is a function, so C has to be paired up with f of C, D has to be paired up with f of D, and then E has to be paired up with f of E. So all this is saying is, we need to find these two tuples as elements of f. That's all this is saying. Now the extra constraint is to say, C has to be the union of some sets. Okay, there are two sets here, A and B. So C has to be the union of those two. D has to be the difference of A and B, and then E has to be the difference of B and A. There's a differentiation, because D can only have elements from A but not in B, and then E can only have elements from B but not in A. And then we also have the standard clause here that says A does not equal to B. A is not a subset of B, and B is not a subset of A, because otherwise, once again, is actually in this case, it's not going to be easy to find A, B, and C. All right, so now we need to look into these items in X here and try to figure out, do we find something that resembles the union of two things, and one is the difference in one way and then one is the difference in the other way. So the union is going to be the one that has more elements. So I'm just going to go by size here. So if I go by size, this one is a good candidate as a union, and so is this one over here. However, if I choose 1, 4, and 5 as the union, then I can only address one of D or E. I cannot address both of them because you can see that we only have one more set here that shares elements of 1, 4, and 5, or at least some of them, and no one else, actually shares 1, 4, and 5. So I know that 1, 4, 5 cannot be the unit that I'm looking at. So that means 2, 3, 6 is going to be the union. So A is okay, wait. So this is not. So we know what C is. Okay, C is the union, but what A is just going to be 2 and 3. And if A is 2 and 3, then B is going to be 6 and 3. So let's plug this in and see if that works. Okay, so when we look at the union between A and B, it's going to be 2, 3, 6, and 2, 3, 6 is right here, and that will meet the requirement of C. And then we look at the difference between A and B. So everything in A that is not in B, that's just going to be 2. And we do have, oh wait, hold on a second here. Okay, so 2 has to be the common element, not the 3. So I got this wrong. There we go. Okay, now it should work. Okay, it doesn't affect the union because when you have a union between A and B, we still have the same three elements, which is 2, 3, and 6. But when we look at A minus B, then we're looking at everything in A but not in B. So that's just going to be the 3, which is here. So that can be our D. And then when we look at E, which is B minus A, that's going to be everything in B but not in A. That's just going to be the set with 6 in it, which is over here. So now we have met all the requirements of A and B. So this one is a little bit trickier because what we are looking for, the sets A and B are not a part of the first tuples of F. Okay, but the constraints will help you locate them within what is given in X. All right, so what F is doing is it's the intersection between A and B. So when A and B are defined like this, the intersection is going to be 2. So F is going to be 2, like so. And then we have to find out what we are adding to F, because we are having a union. So we just do another copy and paste. Okay, so here's the copy. I have a really awful pointing device, which is a Lenovo track point. So for doing stuff like this, it's not really the best pointing device, but it suffices. So now we are adding one more 2 tuple. The first item of the 2 tuple is going to be F here, so that's just going to be the set of 2. And then the second part is going to be based on f of c minus f of d minus f of e. So because c is defined to be the union of a and b, then a union b is going to be 2, 3, 6. And if we look back into the definition of f, 2, 3, 6 has a second item in the 2 tuple is 11. So we are starting with 11, and then f of, what is it? F of d. So f of d is the set a minus b, which is consisting with only the element of 3. So it's the set that only has an element of 3, which is this one here. So the value of f of the set of 3 is 3 itself. And then once again, the f of the set of 6 as the only element of the set is 6. So now we're looking at 11 minus 3 minus 6. So that will give us a value of 2. So that's how we end up with a value of 2 over here. So this is the additional element that we are adding that is not in F, but now it is in H, because H by its definition is the union between F and the new tuple that we are creating here. All right, so now we move on, and we want to know what is in V. So that's really just a copy of X with the extra thing that we added to it. So yeah, I'm really tempted to kind of just say it is X union with something, but let's not be too lazy. And I'm just going to copy X over here and just give it an extra item, which is the set of 2. And then W is almost the same as Y, but we're adding a new value of just 2 by itself. There we go. All right, so this is actually just Y, but we're adding a value of 2 here. So now we look at P of 1, and once again it is guaranteed to be true because of the way that we construct V and W. And in this case it is injective. So since it's injective, there's no need to answer the second part. Alright, so I'm just gonna release this video as well, just so that for those of you who are anxious to know the answer, now you have the answer of another question.